Section 10.3b is about completing the square. A lot of people find that using the square root property is very simple. If you've thought that about the last video, then you're one of those people. Completing the square is a method of making a quadratic expression into a perfect square. So let's say you have a trinomial, a quadratic expression that's not a perfect square. Completing the square is a method that we can do to create a perfect square so that we can then use the square root property. Before we talk about completing the square, let's look at a couple patterns first. Here is a binomial that's squared, and if you FOIL it out, you get this pattern, this perfect square trinomial pattern. And if you simplify it to the end, you get x squared plus 12x plus 36. Now I want you to look at 12 and 36. Can you think of a pattern with those two numbers? Well, 12 is 6 times 2, and 36 is 6 times 6. Okay, well let's look at another one over here. Here we got x plus 7 distributes to become this trinomial. We have the number 14 in the middle and the number 49 on the end. Well, 14 is 7 times 2, and 49 is 7 times 7. Perhaps you're seeing a pattern here. Let's look at one more. X plus 10 squared distributes to become this trinomial. 20 is 10 times 2, and 100 is 10 times 10. So what do you notice? The middle term is always 2 times what this original value is, and the last term is always that original value squared. That pattern is important because it's that pattern that we can use to create perfect square trinomials. So let's try to find the value of c. Let's try to find the perfect number that should go here to make this trinomial a perfect square trinomial. Well, the middle term is 8, and 8, how do you make 8 when you multiply it by 2? 8 is 4 times 2, right? So the number 4 is important. So what number should go on the end here so that it becomes a 4 times 4? Answer is 16. So 16 is the c value that I want to make this a perfect square so that it fits in to this pattern. Remember, the pattern is 2 times the 7 is 14, and 7 times 7 is 49. 2 times 10 is 20, 10 times 10 is 100. 2 times 4 is 8, 4 times 4 is 16. So that's the pattern we're looking for. Here in this one, we want to find the perfect c value. Negative 6 is negative 3 times 2. So there's my negative 3 value. What do I want to do with that? I want to multiply it by itself. And negative 3 times negative 3 is 9. So there's the c that will make this a perfect square trinomial. Here I have a 5. How do I create a 5? By multiplying by 2. What can I multiply by 2 to create a 5? Well, the answer is 5 halves, because I could cancel the 2 and the 2, and that would give me a 5. So this is the number that I want, but I'm going to square it. I'm going to multiply 5 halves times 5 halves, which would give me 25 fourths. That is the c value that I'm looking for. In all three of these values, I circled the 4, the negative 3, and the 5 halves, but those aren't the c's. The c's are those three values squared, which is right here, 16, 9, and 25 over 4. So this leads us to the steps for completing the square. If you have a quadratic expression that's of this form, x squared plus some number times x, here are the steps to create a perfect square trinomial. You find half of b, half of the number that comes in front of the x. You square that. You take half of b and then you square it, and then you add that to the end of x squared plus bx. So this might make more sense if I do a specific example. So here's my example. I want to figure out what the c value is, what the third member of my trinomial is. And so let's complete the square. So I'm going to take half of b. I'm going to take 1/2 of b, which is 5 in this case. So a half of b is 5 halves. That's step 1. Step 2 says to square that result. So take 5 halves and square it. Well, 5 squared is 25, and 2 squared is 4. And then step 3 says to add that to what I already have. So I'm going to put plus 25 over 4. So now I've just created a perfect square trinomial. I know it looks yucky because it has that fraction. Let me do one more that has an even number. That might make things a little bit clearer. So we'll complete the square again. Step number 1 says half of b. b is 8. So we'll take half of 8. Half of 8 is 4. Step 2 says to square that. 4 squared is 16. And step 3 says to take that number and add it to the end. So here's another perfect square trinomial that I created by adding these values on. Now using that in a problem like this to actually solve it is important. So what I want to do is I want to first just get this squared term and this a term alone, because I only need those two terms to complete the square. So I'm going to subtract the 3, leaving me a squared minus 14a. Now I like to leave a space in here, and I'll show you why in a minute. Negative 10 minus 3 is negative 13. Now the reason I leave the space here is because to complete the square, I'm going to end up adding another number there. So let's go to the side here and complete the square. Step number 1 says take half of b. My b is a negative 14. I'm going to take half of that, which means divide it by 2, and I get negative 7. Step 2 says to take that negative 7 and to square it. 7 squared is 49, so negative 7 squared is 49. And step 3 says to add that. But whatever I add to one side of an equation, I have to add to the other side of an equation. So my new equation becomes a squared minus 14a plus 49. But now it's going to equal 36. This is important because I've just created a perfect square trinomial right here. This is a perfect square trinomial. And I'm guaranteed that it is because I just made it happen. I just created the perfect letter C, the perfect value here that makes it a perfect square trinomial. So all you have to do now is figure out what squared gives you 49, and the answer is 7. So this becomes an a minus 7 squared. And now we can use our square root property, which is the point of doing all this in the first place. So a minus 7 equals plus and minus 6. Add 7 to both sides. So a equals 7 plus and minus 6. Two answers. 7 minus 6 is 1. 7 plus 6 is 13. So the two solutions are 1 and 13. Here's another example we'll solve by completing the square. I'm going to move this 5 away so that I can make room for the perfect square trinomial that I'm going to create. So I'm going to subtract 5. That's going to give me a negative 17 over there. So first step in completing the square is taking half of b. My b is negative 18, and half of that is negative 9. Step 2 says to take that number and square it. Negative 9 squared is 81. And step 3 says to add 81 to both sides. Now I've created a perfect square trinomial, x squared minus 18x plus 81, and then over here I'll have 64. Now this is a perfect square trinomial, so we know it's going to factor to something squared. X in the front, it's going to have a minus sign. And what squared gives me 81? Well, it's right over here, 9, but this time it's going to be a positive 9 because it's a plus 81. And then that equals 64. I like 64 because it's a perfect square, so when I take a square root, it won't be a negative, or it won't be a decimal. It'll be a plus and minus 8. Adding 9 to both sides, so you get x equals 9 plus or minus 8. Two solutions, 9 minus 8 is 1, 9 plus 8 is 17. I want to mention one more thing about completing the squares here, and this example is what I'm going to use to do it. I'm not going to complete the whole thing, but I want to point something out back here in the definition. In the definition it says to complete the square you have to have a form like this. Notice the coefficient of this squared term is 1. That's something that I haven't talked about, and it's important. You cannot complete the square if the coefficient of the squared term is something other than a 1. So in the case of this example, you would want to divide everything by 4 so that you'll end up getting an h squared in the front. Here 20 divided by 4 is 5, and then here you're just going to be left with negative 25 fourths. Now you could take this problem and you could complete the square. You could take half of b squared and add it to both sides. I'm not going to finish it, but I did want to point out to you that you must have a coefficient of a 1 if you want to complete the square.